Good afternoon. My name is BP Singh, and I'm the headquarters program manager for the Systems Analysis and Integration campaign. I'm very pleased to have this opportunity to talk to you about two of the research areas that we put calls into this year's CINR. And even though my presentation would be brief, both these topic areas are very important to the campaign and help us fill an important gap in the tool set that we have. So the first one I'm going to talk about is fabrication process for uh, assessments for cost algorithms. And so our campaign, as the name implies, it performs systems analysis and helps our office, the Office of Nuclear Energy, integrate all the R&D activities that are going across, particularly in the Office of Fuel Cycle R&D, but also throughout the Office of Nuclear Energy. And I've listed here on this slide just two of the campaign objectives that pertain to the two calls that we have. So our campaign considers both technical and economic aspects when we evaluate a nuclear energy system. And the nuclear energy system in this context is a complete system from acquiring the resource through mining, for example, all the way through spent fuel and generation of waste forms that come out of it. The specific focus area of the campaign that the first call deals with is development of algorithms for the purpose of having the capability to evaluate economic performance of nuclear energy systems. Now, these systems could be the ones nobody has ever built, and these are proposed concepts that that are being considered, and we are doing R&D on them. And so the effort seeks to understand the basis of costs of various facilities and subsystems by first understanding what's involved in the system, what are the complexities, and then developing algorithms for estimating costs, in part to guide and prioritize our R&D. So I was saying that I was talking about the specific focus area in which this call fits in, and that area has to do with developing the capability through development of algorithms for estimating costs to evaluate potential economic performance of nuclear energy systems. And this effort in part helps us prioritize our R&D. So let me give you some background information. A couple of years ago, we started the effort of developing the cost algorithms, particularly focused on estimating capital cost of various parts of a nuclear energy system, including the reactor, the fuel fabrication, and processing facilities. So having these algorithms helps us in evaluating the potential performance of an advanced concept, but it helps us do so in a standardized manner. So if we are comparing two potential advanced concepts and debating the merits of them, then having a standardized approach helps us make objective and informed decisions. And one of the tools in this area, there's a gap that we would like the proposal to this call to fill. And the basic idea of the algorithms is that it helps us provide insights into what specifically drives the cost so that we can determine those aspects of the system that influence the cost, and we can focus on our R&D, so that we can focus our R&D to reduce the potential cost of those parts of the system to reduce the overall cost. So this slide lists a couple of recent activities that are related to this call. In FY17, we looked at the available information on the costs of large mechanical components, such as the reactor pressure vessel, and developed an understanding of the underlying factors of these costs. And this fiscal year, we are working to incorporate knowledge from the forging industry and enhance our understanding of the fabrication process and as it relates to impacting cost of the various components that are built using forging as the method. So what we expect from the call, in terms of the results, we are expecting the work to provide an understanding of the fabrication complexity of large mechanical components, whether they are end-stamped or not. So the work products will be cost models based on this understanding that are then translated into algorithms for estimating costs. We envision that the PI will engage with industrial partners to gain this understanding at a detailed level that can lead to credible and reasonable cost algorithms. So for example, we expect consideration of all the fabrication steps that are listed in this view graph as they may be applicable, and anything else that may not be listed here. So the cost model, of course, will depend on the type of material that is used. And we are expecting that the PI will consider materials, more than one material, hopefully, relevant to nuclear construction. So as we develop these algorithms and develop this understanding, we hope to gain insights on the major cost drivers for this type of a component. And the final point I want to make on this slide is that we expect that the PI and his team will work closely with the campaign national laboratory personnel to build on the work that's already done, to get the information, and also to make sure that the work that's being done as a result of this call is well integrated into the work products and the tools that we have. So that's all I have on this particular one. And at this point, I invite anybody listening in to propose any questions that they may have.
So for this presentation, since the two topic areas are very different from each other, we will take questions now for this FC5 topic. If you do have questions, please submit them to the GoToWebinar application, and we will relay those to BP.
And do we have Francesco Ganda online?
We do have Francesco on, so
Okay.
let me unmute his mic. Francesco, are you there?
Yes, I'm here. Can you hear me?
Yes, we can hear you.
Yeah. So Francesco, depending on the question, I might need your help in answering that.
Sounds good.
We will delay the next presentation by a few minutes to allow for questions. So if you do have questions, please submit them now. BP, is the emphasis on advanced reactors or LWRs?
I think both. The large components that we use are used for both applications, and so we would expect the algorithms to be generic enough for that type of, so to allow us to use it for both. Francesco, do you want to add anything?
No, I think you covered it. We want both, definitely. And probably we would like to know a little more about the at least because it's easier on the PWR side, because those have been constructed already. But that should be the starting point for us to eventually be able to access also advanced concepts. So that's a very important part of this.
That's the only question we have so far. Let's move on to the next presentation. And if you do have questions for this first scope, please enter them, and we'll have BP and Francesco and others respond to those questions as they come in. So BP, you want to take it away for the next presentation?
Okay, sure. So the next call we have is on interface tool for a transmutation data library. And I'm not going to go over the campaign objectives again because we went through before, but briefly, this call fits into the systems analysis an integration campaign, and one of the focus area of the campaigns is to have a strong capability, both in terms of tools and expertise in analyzing nuclear energy systems. And as I said before, in this context, the nuclear energy system includes all functions of the complete system, starting with acquiring the source material through mining, for example, converting it into fuel, the reactor itself, and subsequent steps leading to the final waste forms to be disposed. And the specific focus area that's directly related has to do with analysis of these systems. And as you can imagine, that such analysis require the capability to consider technically accurate mass flows through the system, and for which a lot of reactor physics, among other things, has to go into it. And so, as part of background, on the next slide, uh, our campaign has developed a tech transmutation data library, abbreviated as TDL, and it's based on years of work done under this campaign, its predecessors, as well as other historical work. And this is an essential tool for performing the analysis, and it contains a vast amount of information for all types of reactors. Having this library facilitates us in conducting the analysis not only efficiently, but also in a consistent manner. I view this as a valuable national resource of information. Now, we do have this information, we're not developing all of it now, but the vast amount of information we have is largely in spreadsheet format. And we've started to put this into a database to improve its usability. And that's where this call fits in, to enhance this capability to easily be able to use this library. So on the next slide, I have a couple of recent activities that are directly pertinent to this call. And we've developed a procedure for importing data generated from reactor physics analysis into the TDL database. And the procedure includes protocols for quality assurance. So both the existing TDL database and the procedure will be made available to the principal investigator for this work. And in terms of products to be generated from this work, first, we're looking for a portable linkage interface between the database and the various tools used for fuel cycle analysis. And two, a software quality assurance plan for the interface tool. The final point I want to make on this call, again, like I did for the last one, is that we will expect the PI to work closely with our national laboratory experts so that their work can build on the work that's already done and can be integrated in an efficient manner. So that's all, and I think I'm ready for questions. Do we have Michael Tedoso online? Yeah, okay, so just unmute his phone.
Okay, once again, please submit your questions. We do have Michael Tedoso, who's the TPOC, on the line. Michael, are you there?
Yes, I am.
Okay, we can hear you.
Okay.
We will hold for the next 2 or 3 minutes to see if any questions come in. Please submit your question now if you would like it answered here live. Okay, we're going to take silence as no one has questions. So thank you, BP. Thank you, Michael, for being available. If you do have questions later on, please email BP directly. His information, Michael's information, Francesco's information is all on the nup.gov website on the R&D tab at technical points of contact. So we will be resuming in about 15 minutes for our next presentation, which will be the MSRC1, which is changed to a program supporting scope. It's on special purpose reactors. So thank you, BP.
Well, thank you. Thank you for those who are listening, and we look forward to your proposals.